Okay, let's kick things off. Every organization out there, big or small, wrestles with this, doesn't it? This constant push to be more efficient, cut costs, improve quality.
Absolutely. It's relentless.
But then you try to make those big changes in the real world, and well, it gets risky, it gets expensive,
Yeah.
and it can really mess up your day-to-day operation.
Deeply disruptive, yeah.
So what if, and this is the key question, what if there was a way to really see the impact of those changes before you spend the money or, touch anything on the production line?
Mm-hmm.
That's exactly what we're digging into today. Plant simulation. It's this really powerful tool designed to tackle those exact problems head on. It's kind of a shortcut, actually, to understanding how industries optimize things.
Right. And what's really interesting is that plant simulation isn't just some isolated piece of software. It's a key part of Siemens Tecnomatix suite.
Ooh, okay. Part of a bigger picture.
Exactly. Tecnomatix is their old platform for digital manufacturing. So plant simulation lets manufacturers, even students, researchers too, build these incredibly detailed virtual models of production systems.
Virtual models, like a digital copy.
Pretty much, yeah. And the huge benefit, like you said, is analyzing performance, spotting problems before you change anything real. That predictive power, it's genuinely transformative, a real game changer.
It sounds like it. Okay, so our mission for you in this deep dive is to unpack what plant simulation really is, explore why it's become so essential for optimizing processes, understand how it works, step by step, and look at where it's being used out there in different industries. We want to pull out the most important insights for you.
Sounds good.
So let's start right at the beginning. When we say plant simulation, what exactly is it?
Okay, so at its heart, plant simulation is what we call discrete-event simulation software.
Discrete-event.
Yeah. It means it focuses on individual things happening, like a machine finishing its job or a part moving to the next station. It models precisely how these specific timed events affect the whole system over time.
I see. So event by event.
Exactly. Think of it like creating a super detailed digital copy. People often call it a digital twin of a factory or maybe a logistics center, basically any kind of manufacturing process.
Right.
It gives you this virtual space where you can, watch operations, analyze how things flow, find the inefficient spots, all without messing with actual production.
Okay, so it's like a crystal ball for your factory floor, but one that's based on actual data.
A predictive model, yeah, that's a good way to put it. And one that crucially gives you tangible results.
Tangible results, even better.
Yeah.
So why is this virtual modeling so critical for optimization? I mean, why can't companies just, try things out, iterate on the factory floor?
Well, iterating on the fly is often what leads straight back to those risky, expensive, disruptive changes we started with.
Good point.
Plant simulation lets organizations basically skip that risk. Imagine a company planning a huge factory refit. Millions of dollars.
Okay.
Without simulation, they might only find a major bottleneck, say, in final assembly, like months after production starts. That means delayed products, lost revenue. It's bad.
Right. Nightmare scenario.
But with plant simulation, they can virtually run maybe a whole year's production in just an hour or so. And boom, it shows them that exact choke point and all the ripple effects before they've even ordered a new machine. That's the shortcut.
Wow, okay. That's a really powerful example. So it's about spotting the log jams before they happen.
Precisely.
But beyond just predicting problems, how does it help companies find new ways of doing things, opportunities they might not have even thought of?
Yeah, that's where it really shows its value. It lets you systematically test all sorts of what-if scenarios.
What if we did this? What if we tried that?
Exactly. You can virtually test completely different factory layouts. You can play around with how you allocate resources, maybe try out some radical new production schedules. See what happens.
And this all ties back to cost and efficiency.
Absolutely. It helps slash costs by, cutting down idle time, making sure you're using machines and people effectively. And thinking bigger picture, it can drastically improve lead times. You simulate scheduling changes and see how it speeds up delivery.
Makes sense.
And it's critical for supporting lean manufacturing ideas. You can analyze where the waste is in your process, all within this controlled virtual environment.
It really makes you wonder, how would you get that kind of deep, data-backed insight without this sort of virtual testing ground?
Honestly, you probably wouldn't, not without spending a fortune or causing massive disruption anyway. So yeah, it's not just fixing current issues, it's actively designing the best future setup.
Okay, so it sounds incredibly useful. How does someone actually do this? What are the main steps involved in using plant simulation for modeling and optimizing?
It's actually a pretty logical process. First step, Define your manufacturing process.
Break it down.
Yeah, break it all down. Every piece. Your workstations, the specific machines, the conveyors, any storage areas, even the people involved.
So basically translating the kind of messy reality of the factory floor into a neat digital blueprint.
Exactly. A structured blueprint. Then second, you build the virtual model using Plant Simulation's object library. It's got tons of pre-built objects.
Like drag and drop?
Sort of, yeah. You use these objects to accurately recreate every step of your real process inside the software. Simple conveyors, complex robot cells, everything.
Okay, you've got the structure, you've built the model.
Yeah.
But for it to be predictive, like you said, it needs real data, right? Not just guesses.
Absolutely crucial. That's step 3, input real data. This is where accuracy is everything.
What kind of data are we talking about?
Things like accurate processing times for every task, how materials actually flow, real-world resource availability like machine uptime or operator schedules and your actual production plans.
And I imagine getting that data clean and consistent can be a challenge in itself sometimes. What are some common pitfalls there?
Oh, definitely. That's a huge point. Often the biggest challenge is just getting reliable, clean, complete data from all the different systems a company might have, ERP, MES, spreadsheets. It can be scattered.
Right, data silos.
Exactly. But assuming you get good data in, then you run the simulation experiments. Step 4, this is where the magic happens, testing all those what-if scenarios we talked about.
Okay, so you're running tests.
Yeah.
Maybe simulating a sudden big order, or what happens if a key machine breaks down, or trying out different layouts.
Precisely, all those variations. And then the final step, step 5, is the analysis and optimization.
Making sense of the results.
Yes. Plant simulation gives you loads of reports, charts, key performance indicators, KPIs that help you clearly see the bottlenecks, the inefficiencies, and based on that, you tweak the design.
So you iterate within the virtual model.
You iterate virtually, yes. You refine the model again and again until you hit the performance targets you want. Then you make the changes in the real world.
That makes perfect sense. A very structured approach. Okay, we've covered the what and the how. Now let's talk about where this technology is really making a difference. Which industries are using this day to day?
Oh, its applications are incredibly broad. You see it used heavily in automotive manufacturing, aerospace too. Industries where you have complex assembly lines, high precision needs, high throughput.
The big, complex manufacturers?
Yes, but not only them, it's also vital in electronics, consumer goods production, places where models change fast and you need agility to handle high volumes.
And it's not just limited to those kinds of discrete manufacturing, is it?
Not at all. It's used in pharmaceutical and chemical processing as well. Think about strict regulations, complex batch processes. Simulation helps manage that complexity.
Right.
And it's a massive tool for designing warehouses and logistics networks, optimizing storage layouts, figuring out the best material flow in huge distribution centers.
So supply chain optimization too.
Definitely. And what's also really interesting and shows its accessibility is that students are using it too. For final year projects, research studies, solving actual industry problems before they even graduate.
That's fantastic. Real-world application right from the start. Okay, let's try and bring this all together then. Recap the core idea for everyone listening. Plant simulation essentially gives you this virtual sandbox for manufacturing.
A safe place to play.
Exactly. It lets you do detailed analysis, optimize things without any of that real-world risk we mentioned at the start. It helps you find those hidden bottlenecks.
Identify them clearly.
Test countless what-if scenarios, potentially save significant costs, improve your lead times, and really support those important lean manufacturing goals.
Precisely. And the key takeaway here is that this isn't just some abstract theory or, a niche tool only academics use.
Right. It's practical.
It's a very practical, very powerful solution being used right now across incredibly diverse industries. We mentioned automotive, pharma, but it's wider than that. And the fact that students are using it effectively just underlines that point. It really shows how understanding knowledge like this and then applying it drives real, tangible progress.
So, thinking about the implications, what does this all mean for you listening? Well, it clearly highlights how digital modeling, specifically tools like plant simulation, are fundamentally changing industrial processes. They're making them smarter, faster, way more efficient than they used to be.
Taking the guesswork out.
Exactly. Taking the guesswork out of really complex, high-stakes operational decisions.
And, that brings us to maybe a final thought for you to ponder, something a bit broader.
Okay.
Think about this core principle. Simulating before you act. Creating a sort of digital twin of a process to test things out first. How might that idea apply beyond the factory floor? Could it apply to other complex systems, maybe even big decisions in your own professional life, or dare I say, personal life? What if you could virtually explore different paths, different approaches, before you actually commit to one?
That's a really provocative question, testing life's what-ifs.
It's a powerful concept, isn't it? It stretches way beyond just manufacturing and sort of invites us all to rethink how we tackle complex problems, really in any field.